Hi guys, welcome to this set of videos and this section of notes. Remember, what we're doing here essentially in this chapter is we're talking about quadrilaterals, which are figures which have four sides. But more specifically, we're talking about a certain kind of quadrilateral, which is known as a parallelogram. In the last section, we talked about the relationships that we know about in a parallelogram, and what we're going to do here in this section is use those relationships to show that a certain figure is a parallelogram. Now, before I get too far ahead of myself, as we always do, let's start with our essential question. What is the main question we want to answer in this set of videos, and then how we're going to go about doing that. So, here's our essential question. You can see it right in here, prove. So I want to know, what criteria can you use to prove that a quadrilateral, a four-sided figure, is also a parallelogram? Because remember, not all four-sided figures will be parallelograms. If it is a parallelogram, we know about lots of relationships we can use to help us solve problems. But you must be able to show that the quadrilateral is a parallelogram. How do we do that? That's a great question, and that's the question we're going to answer here in this set of notes. How do we do that? Well, we got a couple of objectives or learning targets, things we're going to talk about to help you answer that essential question. First, you'll need to be able to identify the characteristics of a parallelogram. What are the relationships in a parallelogram? We've already talked about those in the previous section. We'll talk about them again here. Then we'll use those characteristics to prove that certain quadrilaterals are in fact parallelograms. So, now that we know what we're going to be doing here in this set of notes, let's go ahead and jump right into this. The criteria for determining if a quadrilateral is in fact a parallelogram. Now, there are three different criteria. You only have to show one of the three, right? Either this one has to be true, it'll be a parallelogram, or this one has to be true for it to be a parallelogram, or this one you don't have to prove all three. You do not have to prove all three. In fact, let me number them for you. 1, 2, 3. You only have to show that one of the three criteria is true in order for the quadrilateral to be a parallelogram. You only need one of the three. You do not need to show all three. So here we go. We'll go through them one by one. Here's the first one. If one pair of opposite sides of the quadrilateral are parallel and congruent, then the quadrilateral must be a parallelogram. In the last section, we talked about the fact that opposite sides of a parallelogram are parallel and congruent. So, if you know opposite sides are parallel and congruent, then the quadrilateral must be a parallelogram. If you can show that, you know that it's a parallelogram. Now, a great way to sort of test you on this idea, do you understand what's going on here? I'm going to ask you a question. Let's look at this question. A quadrilateral has two sides. Two sides, those sides are 3 centimeters long. It also has two sides that are 5 centimeters long. Now, a student claims that this quadrilateral must be a parallelogram. Do you agree? Here's where this is an awesome question. We look at it and go, oh yeah, sure, look at this. It has two sides. Let's say that, I apologize, that's my highlighter. Let's say that that side is 5. Let's say that that side is 5, 3, and 3. Sure enough, absolutely, I have opposite sides that are congruent. It must be a parallelogram. But please be very, very careful about the way this is worded, right? A quadrilateral has two sides that are 3 centimeters long and two sides that are 5 centimeters long. It says nothing in this question about those sides being opposite sides, which means I could just as easily draw this diagram to look like this. 5, 5, 3, 3. Are those sides opposite? The same? No. Now opposite sides are 5 and 3, which are not congruent. 5 and 3, which are not congruent. Because the question doesn't tell me that their sides are opposite each other, right? I could just as easily draw the figure like this, in which case, no, it's not a parallelogram. So the idea is this. No, they must be opposite sides. It must be opposite sides in order for it to be a parallelogram. So this student does not have enough information to claim that this quadrilateral is a parallelogram. Just knowing the lengths of the sides is not enough. That is not enough. You need to know that they are opposite sides and that those opposite sides are congruent. Okay, so please be very, very careful with this criteria. It is not enough to just know that you have lengths or you have sides that are the same length, all right? 5 and 5. They have to be opposite sides as well. So please be very, very careful with this criteria. Let's go ahead and take a look at the other two. They are simply this, highlight, if both pairs of opposite angles of the quadrilateral are congruent, and you can see the same thing here. Not only do the angles have to be the same measure, right? They have to be congruent, but they have to be opposite angles, just like above with the sides. Not only do the sides have to be congruent, they have to be opposite sides. Right? There's two things there, congruency and opposite sides. With the angles must be congruent, but they must be opposite angles, right? So please be very, very careful with both of those criteria. And then, of course, finally, the last one here. If the diagonals of the quadrilateral bisect each other, then the quadrilateral is a parallelogram. So if we know the diagonals bisect each other, it must be a parallelogram. All right, so now that we know the criteria, what we'll do on the next page of the notes is go ahead taking a look at a few example problems. Can we show that the figures are in fact a parallelogram? I'll see you guys on the next page.